Now we'll be solving the objective question from the page number 71 of your book. Page number 71 of your book. Page number 71. Okay. So let us go with the objective question number 1. There are options given. You have to choose the correct answer. The product formed during direct combination of carbon and water. Carbon dioxide and water. So do remember, carbon dioxide formula is what? Carbon dioxide formula is CO2. And it is reacting with water. Water formula is H2O. And when these two react, carbon dioxide formula is CO2, water formula is H2O. When these two react, we get H2. This H2 is here. Then C, H2 is here. Then this C is here. Then count O. Here is 1, here is 2. Total 3O. So we get H3, H2CO3. And this compound is known by the name carbonic acid. This compound is known by the name carbonic acid. So the answer is B. Okay. Now we go to number 2. The neutral gas obtained on thermal decomposition of potassium nitrate. The neutral gas obtained during the decomposition of potassium nitrate. So you can see out here, students, this is called potassium nitrate, right? Potassium nitrate is this. And when it decomposes, thermal decomposition means on heating, you get a neutral gas called oxygen. So oxygen is a neutral gas. So the answer, the gas obtained when thermal decomposition of potassium nitrate occurs is which? Oxygen gas. So students, potassium nitrate formula just now I have shown you, KNO3. So on decomposition gives a neutral gas, and that is what? Oxygen. So the answer is D. Now we go to the next question. The displaced product of the displacement reaction when sodium reacts with cold water. When sodium reacts with cold water, what you're going to get out? Sodium symbol is Na. You know in the activity series it is at the top, sodium. Reacting with water, inside water there is hydrogen. So when sodium reacts with the water, it displaces hydrogen. Okay, so the answer is C, that is hydrogen. Next, the catalyst used in the catalytic reaction involving the reaction between hydrogen and nitrogen. What is the catalyst used when nitrogen and hydrogen reacts? So students, when nitrogen and hydrogen reacts, the catalyst uses iron. So the answer is iron. Okay. So students, when catalyst used when the catalytic reduction involves between nitrogen and hydrogen is what? Iron. So the answer is A. A is the answer, that is iron, students out here. Now next one, a neutral oxide which does not react with acid or base to give salt and water. So what is the neutral oxide which does not react with acid base to give water? You can see we have finished the option A, B, C, D. Now what is left? E. So answer will be carbon monoxide, because carbon monoxide is a neutral oxide, students. You can see from here, these are the 3 examples of neutral oxide. And this neutral oxide does not react with neither acid nor with base. Okay, does not react with acid base. So the answer is carbon monoxide, because these two are not in the option. So answer will be carbon monoxide, students. Now we'll go with question number 2. Complete the statement by filling up the blanks. Direct combination of phosphorus pentoxide with water gives what? There are 2 options here. Will you get this or this when phosphorus pentoxide reacts with water? So you can see the bottom reaction here, students. When phosphorus pentoxide reacts with water, you get H3PO4. So the answer will be H3PO4. So students, for this one, answer will be H3PO4, which is here. Okay, you can do this in the book. This you can solve it in the book itself and learn it from the book for your examination. Similarly, fill in the blanks also you can do it in the book and you can learn it from the book. Next, decomposition of silver salt in presence of sunlight is an example of double decomposition reaction or photochemical. You are doing this reaction in presence of light, in presence of sunlight. Light means photo. So it's a photochemical decomposition reaction is the answer. Next, the element molybdenum is used in the reaction of nitrogen and hydrogen. And this molybdenum is what? Is it a promoter or catalyst? And I have already explained you that molybdenum is a promoter, not catalyst. So answer is promoter for this. Next, the reaction of coke with steam to give water gas is an example of endothermic or exothermic. So you can see here, students, coke is reacting with steam to give water gas, and you're getting minus triangle. And you can see here minus triangle means minus heat, which means endothermic. So the answer is not exo, but it's endothermic reaction is the answer. So students, the answer for number 4, when coke reacts with steam to give water gas, is an endothermic reaction. Okay. Now the next reaction. The metal which reacts with steam to and the reaction is reversible is iron or calcium. So which reaction with steam is reversible? So you can see from here, when iron reacts with steam, you get a reversible reaction. So not calcium, answer is iron. So students, for number 5, the metal which reacts with steam and the reaction is reversible, out of these two is what? Iron. So you can do it in your book itself. Now number 3, a thermal decomposition reaction in which a compound decomposes to give two new compounds. You can give any example for this, okay? Because they have not given the specific question. You can give any, but I've chosen this for you. Thermal decomposition means on heating. Triangle means heating. Triangle means heating. On heating, the compound will break down, and that is called thermal decomposition. And I have chosen this reaction for you, which is very easy. Calcium carbonate on heating, it will break down to give you these two. How? Ca plus O will give you CaO. Then here 2O with C will give you CO2. The easiest one. Next, a reaction of direct combination means two will combine to give you one, which is also known by synthesis. Of two elements, it's wrong, it should not be gas, it should be element. Combines to give another gas which turns lime water milky. And do remember, the gas which turns lime water milky is carbon dioxide. The gas which turns lime water milky is carbon dioxide. So when carbon is one element, oxygen is another element. When these two react, we get CO2. And CO2 is the gas which turns lime water milky. Number 3, the thermal decomposition of metal nitrate. So nitrate is NO3. Nitrate is NO3. Metal, I have taken here potassium. And thermal decomposition means to heat, it will break down. And when it breaks down, it will give you what? Potassium nitrate and oxygen gas. So on thermal decomposition metal nitrate, you can take the example of metal nitrate as potassium nitrate. Thermal decomposition means on heating, represented by the symbol triangle, you get potassium nitrate and oxygen gas. Now, as the question is saying you to balance also, this is already balanced, no need to balance. This reaction is also already balanced, no need to balance. But this is not balanced, okay? So this reaction has to be balanced. To balance, we always check odd oxygen. This is even oxygen, this is also even, but this is odd. To make it even, we'll put here 2. 3 2 is 6 oxygen. It became even. So once you make it even here, who will get disturbed? Potassium. So 2 potassium, 2 potassium, 2 nitrogen, 2 nitrogen. Oxygen 3 2 is 6. Oxygen 2 2 is 4. 2 2 is 4 plus 2 6 balanced. Next, number 5. The displacement reaction in which a metal which is above will displace the metal which is below. Metal which is above will displace the metal which is below. So for that I have taken these two compounds. The simplest example, there are many others. Zinc is reacting with copper sulfate, and you know that zinc is above copper in the reactivity series. Therefore zinc will displace copper, so copper will come out and you get zinc sulfate. So this is one of the example of displacement reaction, and good news, it is already balanced, so no need to balance. Done? Now we go to the question number 4. Okay. Differentiate between the following. It will be for 1 marks. Okay. So how will you differentiate thermal decomposition and thermal dissociation? If you have gone through my video, I have said you thermal decomposition is irreversible, whereas thermal dissociation is reversible reaction. That's it. One difference is more than enough. So you have to say thermal decomposition is irreversible reaction, whereas thermal dissociation is reversible. I have explained you. Number 2, neutralization and as precipitation reaction. So you have to say in neutralization reaction, no insoluble particles are formed, whereas in precipitation reaction, insoluble particles are formed. So in neutralization reaction, no insoluble particles are formed. No insoluble particles are formed. Whereas in precipitation reaction, insoluble particles are formed. So one difference is very much enough. Okay, insoluble particles are formed. Now we go to number 3. You can do it with the help of pencil in your book only, this also, because it's a 1 point difference between. What is the difference between electrolytic decomposition and photochemical decomposition? Electrolytic decomposition occurs in presence of electric current, whereas photochemical decomposition occurs in presence of light. That's it. So you have to say simply that electrolytic decomposition occurs in presence of electricity, whereas photochemical decomposition occurs in presence of light. Again for 1 marks. Done. Now no need to do this number 4. Okay, if you want to, you can say job of catalyst is to alter the rate of reaction, whereas promoter is to increase the efficiency of catalyst. If you want, you can say catalyst alters the rate of reaction, promoter increases the efficiency of catalyst. That's it. Number 5, difference between acidic and basic oxide. Do say acetic oxide is non-metallic oxide. I have explained you in my last video, whereas basic oxides are metallic oxide. Acidic oxides, bad. Acid is good or bad? Bad. So bad with the bad person, non-metal. Base is good, so good with the good person, that is metal. So acidic oxide are non-metallic oxide, you can say, and basic oxides are metallic oxide. Okay, students. So this completes question number 4. You can do everything in the book itself, but do it neatly. Okay, and you can learn from the book itself. Now we go to the match the column question here. Now you have to identify which reaction is this out of these 4. You can see AB is breaking into A plus B, so it's dissociation, decomposition, but it is reversible, so it should be what? It's decomposition, but on heating, thermal, but if breaking is reversible, is dissociation. So reversible is always dissociation, so it should be thermal dissociation, D. Next, these two is combining to give you X and Y is breaking to give you X plus Y, that means it is decomposition. Only neither thermal because there is no heat, so it is E, simply decomposition reaction. Now this one, X and Y is reacting with AB where the exchange of ion is taking place. You can see Y is going here and B is coming out here, so it's an exchange of radicals, so it is B, that is double decomposition reaction. Now this one, here you can see X is more reactive and displace Y from it, Y is coming out, and you get XZ out here, so it's a displacement reaction, so the answer will be A, displacement reaction. Answer will be A, that is displacement reaction. Now this last one, you can see this reaction, there is minus heat. Minus heat means heat is absorbed, so it is endothermic, so the answer for this is C, that is endothermic reaction. So by this, students, we come to the end of the chapter. So we have finished the chapter, we solved the question from the back, and notes you can make it as per the lecture was concerned. So you can mark it in the book, when you watch the video, mark it on the book, and okay, make the notes and learn these questions from the back of your book chapter. So thank you very much. I have finished this chapter, so if you want, you can do the revision later on. Thank you very much.